Good afternoon, my name is Jim Stevens, and I'm here to give the EPICS tutorial. This is day 2 of EPICS training, so welcome, thank you for coming. And before I started, I wanted to acknowledge that Ken Evans created the slides for this tutorial originally, and then later, Tim Mooney from SSG created an abridged version. So I just wanted to give them credit before I began. So let's start. MEDM is an acronym for Motif Editor and Display Manager. It's a graphical user interface. It's used for creating control displays. Motif is a widget toolkit that was created for the X Window system, which today is known as X11. It's a mature program. It's been around since the inception of APS. As a matter of fact, it was created here at APS. And today we have over 7,900 displays that are used here at APS. I just want to point out there are other display managers that are in use today. For example, there's EDM and CSS BOY, it's Distillation Neutron Source, and CAQTM, which is used at the Swiss Light source. And this is the primary tool that operators and engineers use to control the APS accelerator. So here we have some examples. On the left is the booster synchrotron display, main display. And as you can see, it's dominated by blue rectangular boxes, which represent related displays that you can launch from the main display, get more detailed information. And for example, on the right, I have 2 examples here, the booster RF ramp controls and the beam position monitor control. Here's another example I put up for people who work on the Beamline would be familiar with this. And this is a Beamline display for personal safety system. And so this is used to monitor beam lines. Here, for example, we have 3 stations. We have doors, we have crash buttons, we have strobes. This is just a passive display. That is, we're not controlling anything here, we're just looking at things. Okay, a little history for MEDM. As I said, it's an APS product created here at APS. Originally, it was started by Mark Anderson. Mark Anderson was hired to work on it, and Mark was an early advocate of Motif. And so much of the look and feel of the display manager is attributed to Mark. He based it on ED and DM, which was originally created at Los Alamos. And so after Mark left, Fred Vaughn took responsibilities for MEDM. He created the ASCII data list file format. The ADL file extension stands for ASCII data list. It's a more efficient way to put the file together, runs more efficiently. He also added features like the strip chart and channel access security, improved the performance of MEDM. Then, after Fred left, Ken Evans took over, and Ken focused on adding editing features like cutting and pasting, aligning objects, making it a lot easier to edit the displays that you're creating. He also created the composite object, which is, for example, like taking 2 objects and putting them together to create one object and allowing you to apply logic to make it appear or disappear on the display. And Ken also added many other features, including animated GIFs. Okay, the presentation I'm giving you here today, what I don't cover or what questions I can't answer, we do have documentation for you. So here I put up a link. There's an MEDM page. And we also have a way to get information from MEDM in execute mode. You can get the help menu. And there's also a web page for MEDM for Windows. Okay, so I thought I'd start with doing a real example of how to start MEDM from a command line. So I have an Xterm, type MEDM, and there you go, there it is. There's the main display. And you notice here we have a big fat toggle button for setting the mode, edit, execute. It starts in default edit mode. And so when you create the display, you can use this toggle button to toggle between editing and executing to see how the display is working as you're putting it together. And also we have a selection for palettes, for view, for file operation. Palettes, I'm going to talk about the 3 palettes that you use to create the displays. That is a resource manager, the color palette, and the object palette. And also there are editing functions that I'm going to talk about. And then the file operations we're pretty much familiar with, you know, open, close, save. So here what I've done is File, New, New Display. And here you have it. This is a default display for creating a new display. Just a gray background, 400 by 400. And if I click inside the display, it'll launch the resource manager. As you can see, all the attributes of the display, the main display, are shown through the resource palette. For example, you have the position, X position, Y position on the screen. There's the width and the height of the display. There's the foreground and background color, the background color being light gray. Now the foreground color is black, and that's because all of the objects that you put on the display will have a foreground color until you change that value. So here the default setting is black. As I said, each object that you put on the display is a set of properties. And the properties, you choose it with the resource palette. Like I said, the attributes, X and Y position, the height and the width. And other attributes for that object depend upon the object itself. For example, you can have text boxes, color selectors, pull-down menus. It really depends on what the object that you're editing is for listing the resources or the attributes on the resource palette. So if I want to change the background color on the resource palette, all I need to do is click on background in the resource palette and it launches the color palette. And here the color palette has 65 colors. So we've got the dominant attribute RGB. There's gray level, black, and light gray. There's some pastel colors in 5 different shade levels. So here, for example, I just chose a beige color on the color palette, and it changed the background color on the new main display. This is the second palette, the object palette, and it's divided into 3 main categories: the graphics, monitors, and controllers. The graphics are graphic objects, like for example, you have a square, a circle. You could draw a line, there's a polyline. You draw text. You can upload a GIF image. Monitors and controllers, it really depends on whether or not you're going to put a value to the hardware or you're going to read it back from the hardware. So controllers, putting a value to the hardware through a text entry field. There's a message button, a choice button. You can execute a shell command. And the monitors, for reading values, you can read from a meter, from a strip chart. You can read from a byte monitor or a text monitor. Okay, here so I've drawn some objects, and because the foreground color is black, I've drawn a square, a circle, an oval, a line, and a poly object. They're all black here. But if I click on the foreground for each object, I can change the colors. So here I've drawn some examples of monitors and controllers. Underneath the monitors, we've got a text entry field. We've got a byte monitor. We've got a bar monitor. And the controllers, there's a toggle button, there's a slider, there's a message button, a momentary contact button, and a text entry field. MEDM editing, all the menus are tear off, and so you can align objects, you can move objects, you can position them on the grid, you can set the edges to grid. For example, for aligning objects, you could have a column of LEDs or circles, and you can select them all and align them using the editing function. You can space them evenly. You can show the grid to help you align objects more precisely on the display. And there's also a help menu in the edit mode for finding out what the functions are and how they work. So like I was saying, you can center and display items horizontally and vertically. You can orient them, you can flip them. You can rotate them clockwise, counterclockwise. You can resize them. And then there's a function called find outliers, and that is if there is an object outside the boundaries of the visible display, there's a way to find an object outside of that range of the main display. The fonts, MEDM fonts are somewhat limited in that when we started with fixed fonts. And the fixed fonts are really determined by the X Windows format. And there's a file that determines what the fonts are going to look like. For example, if you're drawing a font on the display and you're changing the height of the font, you'll notice that the font type changes. And that's because it's referencing it to this file, fonts alias. So, but later, as MEDM evolved, it didn't make it possible to add scalable fonts. But since we've drawn all of our displays here at APS using the fixed fonts, we're stuck with them, so we're going to use them. But people at other facilities, if they want to add scalable fonts, it is possible. There's a way to do it. So I guess the point is that you just adjust the height of the font when you're drawing on the display until it looks good. Here I've drawn some examples of the fixed fonts on the left of the different heights of the fonts. You can see that they change. That is, the font type changes. And then on the right, I've launched the same display. There's a command line argument that you run when you run MEDM in execute mode to say use scalable fonts. And here you see there's uniformity in the font type with the scalable font option. You have the smallest and the largest here for the fixed fonts aren't available. And the scalable fonts don't use the alias file. Like I said, just adjust the height till it looks good. Okay, here's an example of the virtual LINAC display, and this is a display that we use to run the virtual LINAC, which is a demonstration model of how the LINAC will work for people who are visiting APS. We want to show them, how it works. And so we've got sliders, we've got text, and we also have graphics. And so here's a close-up of a graphic widget, which represents a magnet and a coupler on the beam line and the beam pipe. And as you can see, If you're very clever at drawing, you can draw here someone who's drawn the magnets here. It appears that there's a light source coming from above. And so you can give it give the look of the display some dimension here. Okay, dynamic attributes. It's really about change and changing things on the display, making things appear, making things disappear. And we do that with applying dynamic attributes. So objects can appear and disappear based upon rules that you can apply to it. For example, you can say it's going to be visible only if the process variable is a 1 or a 0. There's a way to take an object and apply a rule for the alarm level to make it change to green, yellow, or red, depending upon the alarm level of the process variable. And there's also a way to do it in calculation mode. You can set up a rule between more than one process variable and apply logic between, for example, 2 process variables to make it appear or disappear. There's also, these rules can be applied to a composite object on the display, which I've already talked about. For example, you can draw an arrow and a line, an arrowhead and a line, group them together to create an arrow, and that would represent a composite object, and you can apply some 2 process variables to create a calculation to determine whether or not it's going to appear and disappear on the display. Okay, here's an example of the calc expression represented on a resource palette. Expressions, you can have up to 16 variables, and I'm not going to enumerate them all, but for example, on expression H, you can set it on the high operating output level of channel A, output range of channel A. But for the most part, what you're going to do is focus on these 4 expressions. You can add up to 4 process variables and run a calc expression between the 4 process variables. So here we set the visibility to calc. The visibility calc expression, A is greater than 1. Apply a process variable name to channel A. And there's also a way to make it apply to images, that is GIF images. The calc expressions are the same as what you would find in the EPICS record reference manual. And here's some examples. For example, you can say the value of the process variable for A is 0. It's not 0. The value is equal to 12. Or you can set up a logical expression. A is less than 0, and B is less than 0, C is less than 0. And that example I have from H, the high operating output range, is 90% of the level of the process variable assigned to channel A. Okay, here's an example of the virtual LINAC in execute mode, and what's wrong with this display. All the fields are white on the display. What this means is the channel access connection is lost, and it can be for several different reasons, many different reasons. For example, someone might have disconnected the network cable to the IOC. Someone might have turned off the IOC. It's possible that you don't have a connection between the network subnet that you're looking at the display and that the IOC is running on. So if you don't have a connection, the image on the display will be white. There's a way you can get the name of a process variable on the display that's assigned to an object or a monitor or a controller on the display, and that's to use the middle mouse button. You just hover over the item on the display, middle click on the button, and what will appear is the name of the process variable, and it'll show what the alarm level setting is. For example, here we have ASUS LAP mode, BP mode. So you can drop this value into any motif widget. For example, we have probe or the strip tool, which is a standalone motif application. You can also drop into a clipboard. So this is a quick way that you can find out the name of a process variable that's assigned to an MEDM object on the display. And it doesn't work on a Mac. PV info, here's another way you can get more detailed information about a process variable. And what you do is just right-click on the display and use a cursor to pick an object. And it gives you this detailed information. It tells you what the record type is, for example. It tells you what IOC it's assigned to. It tells you what the alarm level is, what are the states. It gives you a timestamp. More detailed information with PV info. PV limits. Here's a way that you can set limits for meters and sliders, that is, controllers on the display. You can set the high operating output range, the low operating output range, the precision level. And the designer of the display also has control to determine where that value is going to come from, if it's going to come from the channel or if it's going to be determined by the user of the display. So here we have an example where the source of the value is set from the channel. So it grabs the high operating output range of the process variable and assigns it to the slider. Here we determine that it's going to come from the user. The user value is set to 5. So there's drive high and drive low limits, which is the operating range of the process variable. And then hopper and lopper are really going to determine what the range is that's on the display itself. The execute menu is a way that you can access PV info and the PV limits. And the execute menu, when you middle click on an active display that is in execute mode, there's a way that you can add other features to the execute menu. And there's an environment variable that you set. And here I have an example of setting a value for the environment variable for adding the probe feature. So here's the name of the function as it's going to appear on the execute menu. Here's the function itself and the variable it's assigned to it running in the background. And here it is, it appears on the display. So if you want to add another function to the execute menu, there's a way to do it. Just set this environment variable. MEDM macros. Here's a way to save a lot of time and effort in creating displays. And there's another example for creating databases. For example, in the accelerator, we have 40 sectors, and you might have the first sector has an application for power supply system. And so you create a database for that power supply system. Now, since it's very similar from sector to sector, you don't want to recreate another database. So what we do is we put a prefix for all the process variables for that application and just add a designation at IOC init to set that value for that particular database, for that particular sector. And so by the same token, you can do that with displays. And so here I have an example where There's a wildcard setting for the sector and the corrector. And when you execute the display, you can designate a macro setting to substitute for those macros. For example, we have sector S1A, corrector H2. So this makes it much, much more efficient for using the same display over and over. In our example from the virtual LINAC, we do have a macro substitution $user for all the PVs related to the virtual LINAC example. The MEDM relay displays, this is a way to launch associated displays from a main display. And so here we have examples of 3 rows, 3 columns for launching 3 separate displays from the main display. So if you have only one menu, then you're just going to see one label. And clicking on that one label, for example, here the light blue square button will launch one display. And if you have more than one item, it's left justified. And like, for example, I said 3 for the row, 3 for the columns. And there's also an option to hide a display. So if you have a hidden display and you want to find it, there's a way to find that hidden display. You run the execute menu, and then you just hit toggle hidden button markers. And you'll notice that all the hidden relay displays will have a boundary around them, and they'll be moving. So if you click on the hidden display button, it'll bring up one display, a single display, from the main display. Here's an example of LLRF gate. So I drew an example of the bar monitors. And what I did was I took all the different combinations of the attributes that you can apply to a bar monitor. For example, here on the left, you can set the label level to none, no decorations, outline, the limits, and the channel. The channel name, the channel process variable name will appear on the display. The limits will show the limits on the display. And we also have setting for the direction, whether it's going to fill from the left or fill from the right. And then also the fill mode will determine whether or not it's going to fill from the center or fill from the side. So here's an example of using a bar monitor with no decorations to create a bar graph. So the strip chart is not as powerful as the strip tool, which is a separate application that was created using Motif. But it does have many similar features. And what you can do is you can apply a process variable name, set the low limit and the high limit on the strip chart value, set the period for the x-axis on the display, and the unit of measure. You have control of that too. For example, here we set it to seconds. And this particular dialog comes up through the PV limits in the execute mode menu of the display in place of the usual process variable limits dialog box. The last thing I'm going to talk about today is I'm going to talk about Cartesian plots. The Cartesian plots are the most complicated of the MEDM objects. So we have different plot packages that we use for MEDM. The SciPlot was public domain and modified extensively for MEDM, and it should work on any platform. It doesn't have a second axis and the fill under. And so there's a commercial package that we have called XRT graph, which is more popular for MEDM Cartesian plots. It's not available for Windows. We do have a license to use it here on our machines, and the features, as I said, are more popular than the SciPlot. They do have a second axis for the y-axis. And so it works very well. And then at the Thomas Jefferson Lab, they use JPT, which does not support all the MEDM Cartesian plot features. MEDM environment variables. The EPIX display path is a way to set a search path for the ADL files that you're creating, the MEDM files that you're creating. The EPIX CA adder list tells the channel access clients where to look for process variables. EPIX CA max array bytes sets a maximum number of bytes transferred from an array. And this is to set the capacity of transfer between the server and the client. Normally these process variables you don't have to worry about. They're taken care of for you, but thought you should be aware of them. We've already talked about the execute list. So we do have shell scripts which define these environment variables. So that's it. Thank you very much.